Today we shall discuss about soil bearing capacity for shallow foundation. What is shallow foundation? When B is less than depth, the foundation or equal to depth of foundation is shallow foundation. There are different types of shallow foundations such as square foundation, rectangular foundation and circular foundation and a long continuous foundation. For determination of safe soil pressure, we need two types of parameters. One is assumed parameters, another is derived parameters. Assumed parameters is which foundation sizes, length and breadth and depth of foundation approximately. After that we need some determined parameters such as compressive strength, this is compressive strength and unit weight, cohesion, frictional angle, void ratio, bulk density, bulk unit weight, relative density, water table, location, and thereafter we have to calculate the shape factor. There are some uh, equations in IS 6403 for shape factor in respect of cohesion. This is the shape factor in respect of cohesion. It is in respect of surcharge and it's in respect of weights. Here, instead of using directly 0.8, I am converting it to mathematical equation 1 minus 0.2 whole into B by L. These are the shape factor. And depth factor correction is there, which is written in 6403 as 1.3 into df by b. But in respect of 1.3, I am considering it 1.33 since depth factor correction in IS 6403 it is in first part it is mentioned as 1.33. Now another factor is there, depth factor. Depth factor it is given, these are the depth factor correction. I have converted to everything to mathematical conversion instead of writing directly from the quote table. And a most important factor is when there are two conditions of local shear and general shear. For general shear, if relative density is greater than 75% and void ratio is less than 0.55, then it is general shear. Whereas or otherwise it is local shear. So local shear it became 2/3 and general shear it became 100% soil parameters we can be considered. So I have derived this equation to mathematical equation both from void index and from relative density. So we find that the, it is, I term this as efficiency factor. This local shear and general shear, this I term this efficiency factor. I am getting it 0.963 since our void ratio is 0.572. If it is 0.55, then it is efficiency factor shall be 1, but it is now it is 0.963. So accordingly, we require to correct our basic input parameters C using this efficiency factor and phi and Q graph, compressive strength. Now you see another some important factors are mostly people refer to adopt from the curve, which are published in standard textbooks and in IS codes also. But I am trying to explain it mathematically. Here it is and Q, and this is NC. It is N gamma. NC is dimensionless bearing capacity factor used by Terzaghi. So these are named as Terzaghi bearing capacity factor. NC is in respect of cohesion, and Q is in respect of surcharge, and N gamma is in respect of weight. Another equation is there which was used in 1925 by Dr. Carl Terzaghi, who was named as father of the soil mechanics. That is SBC from unconfined compressive strength. A Terzaghi factor which varies from 3.57 to 2.85. In case of square or circular foundation, it is 3.57. In case of continuous foundation, it is 2.85. And correction factor of depth factor, which is 1.33. That's considering all three important factors, we can find out the ultimate bearing capacity. After using a safety factor of 3, we are getting the safe ultimate bearing capacity. Safe ultimate, not it is net or gross. Safe, it is 23.92. In our 6403, this ultimate bearing capacity is C and C SC DC plus Q and Q minus 1 dq sq plus half B gamma N gamma S gamma D gamma and water table correction factor. Water table correction factor in respect of water table, if it is located to the close to the foundation level, then it should be considered as 5. And when water table never expected to raise up to the foundation level, in such cases it should be considered as 1. So after putting this all inputs, we are getting this first component, the cohesion component is 101 and surcharge factor is 6.07 and weight factor is 1.91. Therefore, ultimate bearing capacity is 109.02. Now, using a safety factor of 3, our safe bearing capacity is 36.34. Whereas from compressive strength we have find it as 23.93. So we shall considering 23.92 as a shift bearing capacity up to this extent. Now let us check from the n value. N value, our n value as per after correction, there are two types of correction. One is abundant correction, another is dilatancy correction. So after correction and taking the average, average means actually we must determine this average from considering some other aspect. We have to consider this is our width and it is equal to width. It is half. This portion is equal to half of the width and this portion also half of the width. Let us consider A2 and A3. Now we have to use this equation. This is available in very standard textbooks, Scott, Bowles, Hanson, Bolas. They have recommended 3PA plus 2PA2 plus PA3. With this equation, all seams, all local small seams also included, and we are considering up to 2B, which is called significant depth, up to considering from ground level to significant depth. However, nowadays some most prominent scientists and engineers prefer to adopt 1.5B, which is Westergaard theory. So whatever it may be, I suggest to use 1. Not to use 1.5, but to prefer 2 times. Now using this envelope 16 with a correction factor of 1.49, 1.33, correction factor is 1.33, we considered safe bearing capacity SBC after rearranging the equation 3 of IS 2911 part 1 in appendix B 4.1. In this equation, this equation basically used in pile load estimation with end bearing and frictional resistance. Deducting the frictional resistance, we are considering only the end bearing portion, which is 13 and L by B, and point, since it is can, so I am use 0.1 as a multiple factor to get the ton per meter square. Another earlier equation is, this is I am getting 20.48. Another earlier equation was there, that is 0.4455 n minus 3 into width plus 30 divided by 2b to the power 2 into 10, which is coming 16.28. Accordingly, we are considering our SBC is 6.26. These are all step checking. We may adopt or we may reject anything, because there is no hard and first rule. The lowest should be considered or average shall be taken. Somebody choose to take average and somebody choose to, after considering all aspects, a reasonable judgment is made to select the SBC. Now, lot of queries and lot of questions are always coming from some some engineers and some scientists and basically practicing engineers and young engineers. They are asking what shall be the lateral stability? What shall be the lateral stability of shallow foundation during horizontal load? Yes, we are our design is based on Q by A plus minus M by Z. This is other issue. But there is another equation. We can set the lateral stability also. In this figure, you see this is the horizontal load from this side, and this side also loaded by net superimposed load plus art, uh, earth pressure. And this foundation is it is shear strength of soil and earth pressure. So how it can be derived? There is a standard equation of depth, minimum depth of foundation, which is 1 minus sine phi divided by 1 minus sine phi, and our depth of foundation say it is 2 meter, our weight is this. So, and already we have mentioned what will be this is angle of repose, but angle of repose for clay soil we should consider as 45 plus minus 5 by 2. So, but this 40 is derived. All these yellow marks, mostly all these derived. So, from this equation, we are our SBC is coming 50 ton metric square, which is much higher than the 16.26. So, during horizontal load also our 16 ton is safe enough, and we are adopting a safety factor of 1.3 also. This equation normally maximum foundation engineering handbooks, civil engineering handbooks, Leonard, P.N. Khanna, and Poles. This equation is available. Now another important thing is our SBC means what is SBC? SBC first shape bearing capacity, it should be safe against shear failure criteria, and it will be allowable only if within the permissible limit of settlement. Initially, in earlier conception, the permissible limit of foundations are 1 inch, means 25 mm. But nowadays we are very cannot say that it is conservative, because lot of plate load tests I have conducted during my last more than 50 years of experience. We are always getting very less amount of settlement than the calculated one. But we are obliged to accept the calculated only. So now the IS 1904, they have recommended the various range of settlement starting from 50 mm to 125 mm. Originally it was 1 inch, that is 25 mm. Now it is increased to 2 inch 50 mm to 125 mm for different types of structures and different types of foundation. and foundation soil. They are foreigners. Like some sandy soil or very hard clay, the settlement, the permissible limit of settlement is different, and some plastic clay means soft clay or high plastic clay. These are different amount of settlement. In case of wrapped in plastic clay, it is 125 plus permissible. And we are also sure that the settlement failure is not a, not at all a sudden failure, but the sheer failure is sudden failure. No one get any chance to see what is going on. But the settlement failure, it will be giving some amount of information earlier so that one can take necessary precaution for strengthening the foundations. So we should not fear for settlement failure. It should be only within the permissible limit. Now we see simple simple analysis of settlement. Settlement is normally this is our foundation size, and up to this point this is the point our stress will be 50% at this point, additional stress which will be coming at this point, and this is equal to B plus 1.5B. This will be the width. So we applied here 16 ton metric per square. Say it is 100 ton total load, and here it is the area. This B plus 1.5B area will be divided by the total load, that will be loaded here, and 50% that is loaded here. That is Z is 1.5, dz is 3.5, db is 5.5, which we are considering, which load we are applying to a say to it is 2 by 2 square foundation. Total base area at the bottom, it is 5 into 5, that is 25 square meter. So reduction factor at the center, reduction factor at the load at this point, that is approximately this point load will be decreased to this much, that is total will be 32.7%. So considering the concentrated load, we have to calculate the anticipated total area. To calculate the total settlement, our load is this much, our total weight is 3.5, and compression index, it is determined from the consolidation test, or simply there are two equations recommended by IS 1904, IS 1904 and IS 8009 part 1. There are two equations are there. Compression index equal to 0.008 into LL minus liquid limit minus 10. Another equation is 0.03 whole into E0 minus 0.27. But I do not think the compression index determination from liquid limit is gives some accurate value, since the compression index is a property based on voids only, void ratio only. More the voids compression will be higher, less the voids compression will be less. So it is but the liquid limit it will constant. Less void also it is remaining same, and more void also remaining same. So it is better to adopt compression index either from consolidation test or from void index, which is recommended by 00 IS 009 part 1. That is very approximately, it is within the variation of 10%, both are the same. I have compared the few test results which is coming but almost in 95% or 90%, maximum 90%, only 10% differ, 5 to 10% difference is there, which is not important for approximate calculation. Another is, I am writing here, it is CF, actually it is pore pressure coefficient, which is donated by lambda, and drainage coefficient, which is 1. For lambda there is a standard chart, or we can calculate also, but that can be no hardly any difference. And drainage is, if it is impervious soil or not, it is free draining soil. If it is polygated sand, then it should be half, because in consolidation, if there is a rules which was uh, 19 since 19th century, it is all are following that sandy soil water can easily drain out from the soil media under imposed load. So the thickness of the clay stratum will be reduced. It will be treated as half. But in clay strata, the pore water cannot ooze out easily, which will require several, even 100 years or more. So it should be full significant length should be considered as a affected depth. So for clay soil, this drainage factor shall be 1, and rigidity factor, since isolated foundation are not rigid. Not rigid means for big raft, it is big area, it is rigid. It is a small foundation, so it is not rigid. Though it is, there are some tie-beams or etc. These are only for seismic vibration only. It will not give any relief to foundation design. So rigidity factor is 1. Now, and the correction factor, when the depth correction factor is 1.33, Fox curves give the correction factor of settlement is 0.752. So ultimately it became, you see, total is coming, you see, total is coming 7.99 millimeter. After correction of all these things, it is coming 7.9 millimeter only, which is much less than the 50 mm as per 1904. We have another in IS 8009 part 1 under rule 9.1.4, there is a curve considering some values as ton per meter square against that figure 9 gives some direct value for different sizes against some specific settlement. And there is a condition the shape bearing capacity for unit pressure should be determined according to the according to the required settlement. Our permissible settlement is 50 settlement. So 50 settlement, if our settlement is 17 as per curve and our permissible settlement is 50 so we got the SBC. This is 29.41. We therefore it is greater than 16.26. We consider it 16.26. And what is our minimum depth of foundation? Again we have to seek for depth of foundation. Our minimum depth of foundation is, that is 1.3, 1 minus sin phi divided by 1 minus 5. This is Bowles, Scott and Reynolds. They have recommended this, which is coming considering angle of repose as 40 degree, pressure intensity is 16.26, unit weight 1.03, it is coming 0.97 meter. Depth provided is 2 meter, which is greater than 0.97. Ultimately, what we got? We have calculated gross net non-seismic safe bearing pressure, that is 19.335, that is surcharge, and this we are adding this surcharge here. Our calculated net is 1625 and this is, yeah, and gross seismic safe bearing pressure is, this is immense. But you see, during calculation of gross bearing capacity, gross seismic bearing capacity, we have multiply by 1.25 with this figure, that is 25% we can increase for June 5. So we are increasing by 25%, so it is coming this is. And after adding requisite, adequate and actual size, we are getting this. Now we should not forget there are some other criteria which are more important. The original concept of calculating the SBC for clay soil is 1 by 8 N, that is N value divided by 8 in ton per feet square. And for sandy soil 1 by 12 N, that is N divided by 12 for sandy soil, which is approximately equal. I have calculated comparative, I made some comparative statement. These are almost equal. Later on, later age, Tarzaghi have developed one equation C N C Q N Q and gamma N gamma. After some time back, after careful observation, and Tarzaghi itself mentioned that this equation is valid for foundation at ground. Foundation at ground. No one put foundation at ground except the road pavement. So, after study by Tarzaghi, Peck, Hansen, Thunberg, this value, the SBC shall be accurately determined using C and C, SC, DC, IC plus Q, NQ, SQ, DQ, IQ, half gamma, N gamma, B gamma, D gamma, Y gamma, water table correction. But initially Tarzaghi adopted three types of safety factor. One is 1.5 against elastic limit, another is 2 as tolerable limit, and 3 against shear failure. And settlement during that time, settlement was considered as 25 only. Now you see, at present, at present the equation has been further modified. Further modified. The, initially it was Q and Q as Q, DQ, IQ. Now it is Q and Q minus 1 SQ, DQ, IQ. This is the some development. New concepts have been developed and accordingly it is accepted by all. We further we should not forget one thing. The soil mass is isotropic, soil mass is semi-infinite, soil mass is elastic, soil mass is homogeneous. And soil has different meanings as according to uses. To a geologist, soil is the most unconsolidated soft weathered rock available at earth crust. For engineer, soil is a construction material. Soil is a very good construction material. For agri biologist, agribiologist, for agricultural people, for them, soil, the earth material of earth crust which support vegetation and plantation is soil. And the geotechnologists, people like me and you, considered soil is the most complex substance of this world. I do not think so. Because you see, complexity is a metaphysical phenomenon like existence of God in our soul. So if you think more complex, it will make you more problem, create you more problem. If you consider a simple approach, then it is very easy to choose. One saying of Bowles I am remembering, Bowles says, the simple approach of any problem, it is very easy to solve. If you cannot solve by simple means, it cannot be solved at all. So, for today, I am discussing the shallow foundation of clay soil, and tomorrow I shall be discussing for shallow foundation on sandy soil. If you have any inquiry or anything or any clarification or make you any contact me, I am JC Gogoi. I can be contacted at JC Gogoi at the rate gmail.com. I am again telling you my mail ID is jcgogoi at the rate gmail.com. Anyone can contact me. I am free to all. I have no any complication or complexity. I am very simple. Please have a nice day.